Welcome to Unit 1, Level 1 video notes, where we will be focusing on the standard that solves routine 2 or 3-step problems that involve proportion. First, we will review some vocabulary. A ratio is a comparison of two numbers. So this could be side length 3 to 4, and we can write that as 3 to 4. Or as a ratio with a colon, 3 to 4, or as a fraction, 3 to 4. A scale factor is a number which scales or multiplies some quantity. So if I was going from the small triangle to the big triangle, I would write 3 times what equals 4. And if I solve that, I would divide by 3, and I would get a scale factor of 4/3. So that means that 3 times 4/3 is 4, or 6 times 4/3 would be what? And that would be 8. So that means that the big triangle is 4/3, or 1.3, repeating, times bigger than the small triangle. I could also find the scale factor from going from the big triangle to the small triangle. And that would mean 4 times what equals 3. If I solve for this, x would be equal to 3/4, the scale factor, or 0.75. So the small triangle is 3/4 the size as a big triangle, or times 0.75. A unit rate is how much of something per 1 unit of something else. So this could be like saying 30 miles per hour, and that would be 30 miles per 1 hour. Or it could be how many heartbeats per minute. And if I went to the grocery store and I was comparing toilet paper, I could say, hey, it's $15 for 24 rolls of toilet paper. If I divide that out, I would get 0.625, which is about 63 cents for every 1 roll. So that's a unit rate because it's 1 unit. I can also find out what's the better deal by if there was $12 for 16 rolls of toilet paper. If I divide that out, I would get 75 cents for every 1 roll. So by using unit rates, we can find which one's the better deal, and this one would be the better deal. A proportion is 2 equal ratios or 2 equal fractions. So 1/2 would be equal to 3/6, and that common scale factor would be times 3. Or if we had 3/6 being equal to 1/2, the common scale factor would be dividing by 3, which is the same as timesing by 1/3. All proportions can be solved by cross multiplying. So if I'm given 2 fractions that are equal, then their cross products are equal. So if I multiply A times D, that product would be equal to B times C. And from there, I could solve. Let's look at our first example. Here, Ralph sold 16 computer games for $180. At this rate, and rate is a comparison of two different numbers, which is like a ratio, how much would he get for 20 computer games? So our question is, how much will he get? And how much would be money in this case? So we can see that we're comparing 16 games for money here, and we need to figure out the money for 20 computer games. So that is a proportion where we could either do how many games per dollar or how much money per game. And I like the idea better of how much money per game. And since these are 2 equal fractions, we have to make sure that we set up the fractions equally. So the first one, we have 16 computer games for $180. So here's our rate. At this rate, how much would he get for 20 computer games? So we do not know the unknown price, but we know that he wants to know how much he would get for 20 of them. So we know that money to games here is equal to our known to games here. When we cross multiply, one of the cross products would be 16 times x is equal to the other cross product would be 3,600, which is 180 times 20. Now to solve this equation, we would say 16 times what equals 3,600, and we undo multiplication with division. In the end, we would get x equals $225. And good mathematicians check our answers. So 16 computer games for $180 would be the same as 20 computer games for $225. If I plug this in and divide these out, they would have the same value. 180 divided by 16 is 11.25, and $225 divided by 20 games would be $11.25. So for each of these, they're getting $11.25 for every one video game. Our next example is about a candy maker, and she estimated that she had 3,500 bags of candy, and this was a total. She put prizes in 101 of them. So 101 of them out of 3,500 bags of candy had prizes, and that's a rate. So 101 bags had prizes out of a total of 3,500 bags. She collected a sample size in which there were 10 bags of candy with prizes. Approximately how many bags of candy were in the sample that the candy maker collected? So we want to know how many total bags of candy she had if 10 bags of them were with prizes. So this is scaling down this huge ratio that she has so far into if she only had 10 bags of prizes, how many total bags were there? So let's use a cross multiplication or cross products to solve. 101 times x is equal to this product, and 3,500 times 10 would be 35,000. Solving this equation for x, we'll divide by 101 because we're saying what times 101 equals 3,500. And when we divide that, we get 346.53. It says approximately how many bags, so we would have to pay attention to rounding. But in this case, we'll just round to the nearest whole since there's not a specification. And we'll say it's 340 instead of 6. We'll look to the right. Since it's 5 or above, give that a shove. So there's about 340 bags of candy in the sample where 10 of them had prizes. Now, good mathematicians always check their answers. And 101 divided by 3,500 is 0.0288514. And now I'm going to check what's 10 divided by 347, and that is the same decimal. So these two fractions have the same value, making them a proportion, which are two equal fractions or two equal ratios. Good luck with your Unit 1, Level 1 assignment.